So we have Mike here again. He's a developer advocate for IBM, and he will be talking about microservice architecture. He will give an overview as to why he believes it's grown, why is it great, and some handy ways of doing microservices together. Mike?
Oh, can you hear me? Same deal as before. Hi. There we go. There are people waiting in the room. Really? Right. So once again, I work for a giant corporate. This is so I can talk about what I want to in front of you. Done. Moving on. I'm Mike Elsmore, developer advocate for IBM. There are my contact details. There's my email if you want to spam me. Go for it. Don't care. I work for IBM Cloud-based services. Our entire job is operation in databases. I apologize to the people who saw me earlier, but it's the same spiel I do every time. So we make all the open source databases available to use the SaaS service. The only two on that list that aren't open source routes is that one, which is Twitter, and that one, which is DashDB. They're things. But the rest are open source. Who here recognizes some of these names? Same hands that came up earlier. Great. So, my day starts like this. Around lunchtime when I've done some code, I do this, trying to work out what the code was, and I usually end up like this by the end of the day. Because I have no idea what my code was. Just to correct the title of my talk, I should really say that, because people keep complaining about the fact that port 80 is no longer secure. I don't care, it's a funny title. So, if people are still thinking, what the hell am I talking around? It's microservice architecture. This is taking those huge applications and breaking them down into their much smaller components. They become services. Am I speaking to the right audience? Yeah, good. So, it's time for a story. Possibly the worst story you'll ever hear. Hi, I'm Monolith. This is what people were building like 10 years ago. Who here has been dev for longer than 8 years? Right, so the first few slides are going to make you go, oh, Jesus Christ, not this stuff again. So, this is the monolith. Monolith does not equal legacy. Monolith still exists. LinkedIn famously went from being a monolith to a microservice, and they went back again when they realized microservices didn't do the job they needed, which is fair. However, when most people think of monolith, they think of this thing. You know, all the dependencies, all the modules, everything built into one giant artifact which is then dumped on a server. Is that generally what people consider to be a monolith? Right. Do you generally have this opinion after you've looked at code like that? Yeah. However, this isn't the truth of it all. You can have what's called a modular monolith. So something that looks quite nice. It's broken down into individual components and then built into a deployed artifact, which is then deployed into whatever is necessary. It turns out monoliths can be servicey and kind of look nice. I like this example, which is Apache CouchDB. So, that's just a bunch of their services, which they then build into one giant Erlang application. You know, it's a monolith, but it's built well, it's modular, it's easy to control, which is one of the major things with microservice architecture, is easy to maintain control units. There's this thing called the allocation monolith. Who's heard of that term before? Yeah, usually it means you're using only parts of the application, but you're deploying the whole code again. So you can have different versions of the application available at any one time. So you can have a V1 and a V2 because you still need the V1 functionality, but you need the V2 right there because that's what you're actually building. It still means deploying a whole stack again, but it does allow for a slightly more flexible thing. So monoliths aren't all evil. When they are evil is when they're the runtime monolith, because that's the exact same code everywhere. There's one giant hunk of I'm wasting your space. Then there comes in service-oriented architecture, otherwise known as SOA. Who remembers this stuff? It's a big deal. Or was a big deal. SOA isn't microservice architecture in its truest sense. SOA is, well, what is it? It's very much... I spoke really fast earlier, sorry, I ruined my voice. I apologise, I'm going to take it a little slower this time. Service-oriented architecture is taking different applications and providing a common layer for them to interact and put forward as a single application. So the core concepts of these are consumer layer, business process layer, the services layer, the service components layer, and finally the operational systems. This is like a bunch of stuff that you really don't need, because that's essentially, top one is the UI, next one's the API layer, the third one's the kind of bit that's the API layer, the next one is kind of when you offload it to third parties, and the bottom one is, oh, your waiting database. So you end up with these horrible diagrams. Who remembers seeing those for their like service architectures about 4 or 5 years ago, and then just go, somebody really should stop using Excel to plan things. Yeah, they're horrible big things where they've got so many different abstraction layers which are completely unnecessary. Enter microservices. You know, this wonderful thing that's been growing really for the last 3 years to begin with. They are different from service-orientated architecture. SOA is loosely decoupled pieces which glue together via common code sets. Microservice architecture is very much different. It's highly decoupled units, things that are independent code units which you then communicate with as if they were completely separate services from each other. This has some major advantages. One thing, you can pick whatever code you want to write with. So if you're doing high-level data science, chances are you're going to be wanting to use something like Python. If you're doing some really, really dirty audio transcribing, etc., chances are you're going to want to throw it through Rust or Go or even Node, but you're not going to want to throw it through PHP. So you can pick the language you need to do the job. So you have these small units of things which are completely self-contained, completely tested independently, and work fantastically for that one job that you gave them. It also means you can have nice architectural diagrams like this where you can have your user database, which is a Ruby app with a Postgres database. You can then have your business warehousing tool built on top of Spark and Python interface, because Python happens to work better with it for some reason. You can have Node.js and CouchDB because, well, CouchDB. You can throw Go and S3 directly out to the front end because you want to have a really fast image resizing algorithm where you don't want to have to then throw it underneath the rest of your API sets. You can re-architect things, having the services available where you want them and where you need them. So, we all love microservices. General thing. Now for the opinion time. Don't quote me on any of this stuff, because I'm probably wrong about most of it. So, why has this thing grown? In my opinion, the birth of commodity hardware and the fact that things like AWS and Heroku and everything else has just made everything so cheap and easy to break things down into the smaller units and sell them. Even VMs, being able to roll a VM onto any form of Linux machine and just go, hi, I can put 15 of the things on a big fat tin that cost me a lot of money. There, microservice architecture for you for a big company. But it also it's evolved with the practices of distributed computing. The moment you started needing information in India, North America, China, everywhere simultaneously, so it be as fast as possible, you need to start being able to have highly repeatable pieces of code everywhere, which you can't really do if you're going, here, big piece of tin, let's install the same version of Linux. Oh, that's not secure anymore, I'll have to install the new one. Okay, that's not going to work. Stop. So you have this entirely repeatable process. I do have an example I like to use because it makes me have some very nice pictures in there. Mainly, I used to do these things called battle hacks, big hackathons that went around Europe. I managed to win one a couple of years ago and looked like an absolute idiot, like a little troll, with pulling my photo for it. Oh, and yes, we did get to keep the access. But in the space of 24 hours, we built a ridiculously large system using all of these. This is just 4 guys in 24 hours building a... I mean, what was... does anybody here remember the movie Minority Report? Do you remember that really creepy bit when it just started throwing ads at him based on his eyeballs? Yeah, we decided to build a really creepy version of that used facial recognition. So you'd walk around the room and it'd throw ads at you and also track you. Yeah, we didn't realise how creepy that was until after we built it. But the only way that 4 guys could build this in the space of 24 hours without destroying and nuking each other was to build them as small independent blocks. So that just proves it. You can, well, that's my belief. Hence the reason why it's an opinion, not a fact, is that you can just drop all these really small componentized pieces together and just make them work. And here are some of the repos. We ended up having 18 repos to build the entire app. And that's 18 repos for one hack project. Most people will do that a weekend in one repo on their own because, well, they're on their own doing that. We went nuts. So I like microservices, and I really do like the way they come together. But there are some bad sides. I've spoken with a lot of developers, and this stuff makes me hurt. This is the first one, the biggest pain in my life. Let's insert the expletive there. I like to call that the infinite HTTP stack, where somebody has decided to put a HTTP layer, and another one that's calling it, that's calling this one, that's calling this one, that's calling this one. And it's like 15 deep. Oh, I'm getting a 30-second response time. How many HTTP requests are you making? Seriously, you can, just because it's a simple idea doesn't mean you should be doing it like that. Sometimes you put more thought into what you're building and build it with some actual pretense rather than just smashing it out like a bad thing. I also like this one, which is an exhibit. If you can't read it, it says, "Yo, dog, I heard you like microservices." So I put a reverse geocoding service in a Q service, in a Facebook service, in a Twitter service, so you can microservice whilst you microservice. Yeah, that sounds like a great idea for something that's maybe in production. But what do we care? It's microservices. It's quick and fail. Write them and run over again. Yeah, that's until you... Jesus Christ! I'm awake now! Right, as I was saying, just because you can build these things and they can be connected loosely to everything else, you can get, well, highly disconnected but loosely connected, you can get this wonderful diagram there. Can anybody here tell when any of those lines are going? Ignoring the fact it's a really pixelated image. Yeah, so you can get these horrible architecture diagrams afterwards where you just keep following the network traffic and realizing, I actually have no idea what's using this or where it's coming from. But which essentially means that you end up with this thing that it's kind of working because when you unit test it, it's running, but the application doesn't work. There are ways to avoid these sort of problems. There's a great talk by a guy called Paul Hadd from List in London. He gave it in DjangoCon this year in Budapest about microservices and how they went about it. I forgot to put the link into the slide, so if anybody's interested in that talk, come and catch me afterwards and I will give you the link. But the biggest pieces are things like this, repeatable services. So being able to template, so things have the same tests, they have the same sort of API layers, they have the same repeatable pieces so that one team has the same code as another team, so that when you move from team to team, you know what's going on, you know where things are going to go. How does that sound as a good example, good way of solving that? Oh my god, everything's so different, I have no idea where it's going. There's also the other common channels. You don't have to HTTP everything, people. There are all these great things. HTTP, yes, you can put it in a queue. You know, these things that have been around for a long time in message bus services. There's WebSockets as well. If you've got something that can listen to a WebSocket, my god, you can have a microservice that can sit down in the background. You don't have to worry about it being hooked up into some weird-ass HTTP response. It can just give you the information later. And then there's WebRTC and peer-to-peer. It turns out, if you're doing a front-end application, you don't need to send everything to the server. You can just make the peers talk to each other and use them as a service themselves. That saves a lot of overhead, right? And then it's like, if you need a really quick thing, you need to run it as a reaction to something, but you don't care about having a response. You can throw a goddamn TCP request at it just to trigger something. Jesus Christ, you don't have to do the same thing over and over again and just cause yourself more headaches later. Ah, I've managed to do this really quickly. So I'm like Elsmore. There's my slides. That's because he blew it out, definitely.
Yeah, okay, so are there any questions?
I'll take heckling as well.
Okay, I'll have the first one.
Okay.
So what's the danger of having everyone in your company using different languages in order to code these microservices?
The problems, skilling up everybody to the right level. You can have the good old-fashioned bus factory in there. If you have one guy that's written something in C# because he's the only C# dev there and feels like, you know what, I can do it in C#, I can do this on my own, that's a buzz factor of 1. That's a bad idea for anything that goes into production. But on the other hand, it does mean if you have a large team of people, web devs, for example, who here's a web dev? Who here writes in at least 3 languages doing that one job because they're using JavaScript and at least 2 server-side languages? Okay, so if you have a team of people, you can pick at least 3 languages that work for it. Good.
Yeah, so we're talking about microservices. When do we know that they are smart enough?
When do we know that they're smart enough? When they start killing us like robots? There's never going to be a smart microservice. The entire idea of a microservice is they're meant to be stateless, completely separated units, which means in actuality, they're pretty freaking dumb. If you have a smart microservice, that's called a monolith. That's called a full application. I'd worry.
Small.
The question was, small. When are they small?
Yeah,
Small enough.
It's micro. How micros?
I've seen image manipulation algorithms which are running on about 20 lines of code in Go. Now that was an entire microservice on its own, just doing the whole resizing around of focal points. That's a microservice. It's doing one job and it's doing one job really damn well.
Okay, but that's just a single responsibility.
That's a microservice.
The same old pattern.
Yeah, it's the same old pattern. It's just picking the... As I said before, LinkedIn went from monolith to microservice and back again because they realized it didn't work for them. Obviously, microservices are the in thing with the fact that Docker Swarm, Kubernetes, am I saying that correctly? Can I just pronounce it? Wait for a response. Thank you. Kubernetes. It means you can roll all these things really fast at scale, but it doesn't mean it's always going to fit your use case. So having really small, unique things, great. Sometimes it just doesn't bother because it's not worth the effort. Next. I'm actually quite happy and bouncy. I'm just deciding to be an idiot. As well. You can always shout.
That's exactly what I wanted to do. So I read something about modularity tension.
About what?
There is this concept called modularity tension. This means that to find the sweet spot of how modular something is or how monolithic it is, in your opinion, how do you find this balance? How do you maintain it in your applications?
I think that's the time to finish. Personally, dealing with the teams I do in IBM, because there's some rather large and distributed teams, I think the sweet spot comes when the amount of time you're spending on DevOps and maintaining is less than the time you're spending building it. That's the sweet spot. When you're spending more time on DevOps than building new features, it's probably something's wrong.
So basically you suggest, from your experience, you see that if you spend some time more than allowed on actually maintaining things, it's already too modular.
If you're having to spend more time doing bug fixes because of reasons, because there are many, yeah.
Try and error and learn from others.
How else do you learn? Anybody else? I'm waiting for someone to abuse me with a really hard question. Okay. Thanks, guys.